Namaskar. The topic of discussion today is on origin of ocean basins. Oceanography is the scientific study of seas and oceans. It is an interesting and interdisciplinary science. It includes the subjects like geography, geology, chemistry, physics, biology, climatology and engineering. Oceanography mainly deals with the following aspects: the geological features of ocean bottom, physical conditions with reference to ocean water and its temperature, chemical composition of sea water and marine sediments, biological conditions of marine life which include the fauna and flora, the role of oceans in controlling the global climate, navigation and the economy. The origin of ocean basins is an important aspect in oceanography. Oceanography is also further divided into geological oceanography, physical oceanography, chemical oceanography and biological oceanography. The geological oceanography deals with several aspects of seas and oceans. The essential aspects are origin of water and air on the earth, theory of continental drift and crustal blocks, theory of plate tectonics and continuing dynamics of ocean basins, the spreading of sea floor, the distribution of ocean basins and coastal geomorphology. The geological oceanographic studies also deal with the following aspects: morphology of ocean bottom and relief, marine sediments and deposits, coral reefs and beach processes, coastal disasters and management, air-sea interactions, and the study of marine sediments, submarine canyons, underwater topography and corals. At present, Earth has about 1.3 billion cubic kilometer of water. This amount is present mostly in the form of seas and oceans. Because of this, the Earth is called as a blue planet. Three important spheres make the planet Earth as a unique member of the solar system. They are the atmosphere, hydrosphere and the lithosphere. Their combined role lies in the sphere of all living systems on Earth. First of all, it is necessary to understand the origin of land, air and water on the Earth. The origin of water and air on Earth is almost related to each other. The reason for the occurrence of such a huge mass of water on the globe is still a myth and reality. The reason goes back to the origin of Earth itself. The exact mode of origin is not precisely known even today. Scientists assume both primary and secondary sources would have given rise to both air and water on the Earth. Two possible sources as internal source or external source have been proposed so far. Some of them are attributed towards the theories of origin of Earth itself. Let us see the origin of Earth and its theories. Many theories have been proposed so far. The planetesimal hypothesis of 1749 proposed by T.C. Chamberlain on the origin of Earth was probably the first idea about the birth of the Earth. Later in 1755, Immanuel Kant has proposed the ancestral nebula theory. Nebula containing cloud of gas and dust leading to the generation of planets from the sun was the theory proposed by Immanuel Kant. The nebula was considered as a hot gaseous material, and hot gaseous nebula was thought to be rotating with great rapidity initially. It also underwent cooling and contraction, due to which the speed got increased. Due to strong centrifugal force along the equator, the materials were thrown away as successful rings. These rings cooled down to form solid and liquidous masses at a later stage. The same process have happened to planets to form their satellites also at a later time. This diagram shows the structure of a nebula, where the gas pressure is attempting to expand the clouds. This diagram shows the equatorial bulge of the nebula which gradually gets detached from the nebula in the form of rings. This diagram shows the release of protoplanets which happened in sequence. Collapsing protoplanets further released their masses as satellites. The ultimate celestial output are the birth of various planets. The first set of protoplanets were released with more gas available with the parental source. That might have come as a flat ring to release all outer planets one by one. The bigger size of all outer planets came in because of this. Outer planets are also lighter planets. Initially, embryonic continents were formed due to cooling. Partial melting of the mantle produced the volcanic rocks like basalts that were little in silica. Origin of a single continental mass was created. That continent was called as Pangaea. The name Pangaea means all earth. Pangaea was a supercontinent consisting of all the earth's land masses. It existed from the Permian period through Jurassic period. This diagram shows the structure of Pangaea roughly about 225 million years ago. Outgassing from the earth's interior has poured out water masses through eruption and other reactions with the atmospheric gases. Atmosphere also helped with sufficient pressure for precipitating the water on the planet. Condensation and precipitation continued for several thousand years to form the oceanic water masses. Infant Earth grew in size, successful in capturing free atmospheric molecules to form water masses. People also attributed to the biochemical synthesis through mineralization and photosynthesis for the presence of water on the earth. Gradual leakage of water molecules stored in hydrous minerals of the earth's rocks was also considered as a contributing factor for water on earth. Photolysis was also another mechanism. The radiation can break down chemical bonds on the surface of chemical masses. The next category belongs to the internal sources. A sizable quantity of water would have been available within the material which formed the earth initially. Water molecules would have escaped earth's gravity more easily when it was less massive during its early stage of formation. The internal sources provided carbon dioxide, water vapor, nitrogen and other gases also. Many gases were provided by volcanic eruptions, hot springs and geysers. All of them are earth-borne sources. Primitive oceans were first formed from the water molecules released from the interior and also the atmospheric precipitation. These water bodies joined together to form seas and interconnected oceans over a period of 4.6 billion years. The extraterrestrial sources also thought of contributing for water on earth. People also attributed that the earth's water was originated purely from comets. This was done as a result of measurements of the isotope ratios of hydrogen in the three comets like Halley, Hyakutake and Halley-Pop. The shapes of continents on opposite sides of the Atlantic Ocean was noticed by several scholars. Even today, we amazingly see this feature. It was in 1596 Abraham Ortelius put forward the hypothesis of continental drift. In 1858, Antonio Snider Pellegrini illustrated the closed and opened Atlantic Ocean with a diagram. This is the diagram which has been proposed by him. One can see all these features in this illustration, that many of the continents are united together with their boundaries similar to each other. These observations forced the ancient scholars to work on the distribution of continents. This led the birth of continental drift theories initially. Let us see the Alfred Wegener's hypothesis. According to this concept, about 200 to 300 million years ago, all continents were attached together as a single land mass. That single land mass was called as the supercontinent as Pangaea. Thermal expansion and volcanic activities broke the Pangaea into new continents. These new continents drifted away from each other due to further expansion of rift zones. Wagner was the first to use the term continental drift. There are several evidences available on Earth to support the theory of continental drift. Similar fossil patterns across many adjacent countries is one among them. The Mesosaurus skeleton, freshwater reptile found in Brazil and South Africa, is another evidence. Land reptiles like Lystrosaurus, fossils from the rocks of same age from locations of South America, Africa and Antarctica are another evidences. Several living animals are being found on different continents even today. The widespread distribution of permocarboniferous sediments in South America, Africa, Madagascar, Arabia, India, Antarctica and Australia is another evidence. The oriented glacial striations and deposits called as stellites in the Gondwana land was another evidence. Similar coal deposits existing in the eastern United States and Siberia is one more evidence to support the theory of continental drift. Rocks of different ages show a variable magnetic field directions. Magnetic north and south reverse through time, which have been seen in different rock types. Initially it was considered as polar wandering, and later it was attributed to paleomagnetism, and finally it has led to the theory of plate tectonics. People mistook the paleomagnetism with reference to polar wandering. The study of paleomagnetism came after these studies. This has provided the geophysical evidences to support the movement of lithospheric plates. The word plate here technically refers to the rock mass which is available on the crust. Early in 1953, scholars have introduced the theory of plate tectonics. Jack Oliver, a geophysicist, provided many seismological evidences for these findings. Continental crust, oceanic crust and lithospheric plates were identified as unique features after this. Scientists believe that below the lithosphere there is a relatively narrow mobile zone in the mantle called as asthenosphere. This zone is composed of hot semi-solid material which can soften and flow after being subjected to high temperature and pressure over a geological time. This rigid lithosphere is thought to float or move on the slowly flowing asthenosphere. This diagram shows the position of asthenosphere in the interior of Earth. It illustrates the location of asthenosphere approximately 100 kilometers below the surface and 60 kilometers below the continental and oceanic crust. Lithosphere is broken up into 7 to 8 major tectonic plates and several minor plates. These plates are viscoelastic solid rock bodies. A tectonic plate is a massive irregularly shaped slab of solid rock. The plate size can vary greatly from a few hundred to thousands of kilometers across. The Pacific and Antarctic plates are among the largest plates. Plate thickness also varies greatly, ranging from less than 15 kilometers for young oceanic lithosphere to about 200 kilometers or more for ancient continental lithosphere. Plates ride on the asthenosphere. The radiation from the Earth's interior generates convection currents which move the plates apart. This diagram illustrates the movement of plates due to convective currents. The convective currents move the plates apart, so there will be sideward movement of plates when the heat rises up towards the crust. The theory of plate tectonics describes the large scale motions of Earth's lithospheric plates. Plates move in relation to one another. The location where two plates meet is called as plate boundaries. These areas are commonly associated with geological events such as earthquakes and the creation of topographic features like mountains, volcanoes and oceanic trenches. Plate boundaries are the home of the majority of the world's active volcanoes, with the Pacific plate's ring of fire. Plate movements happened along three types of plate boundaries called as convergent boundaries, divergent boundaries and conservative transform boundaries. Let us see the Earth's crust and asthenosphere, where two plates collide each other and where two plates move apart from each other, and the diverging plate goes into the earth, creating a lot of structures above the surface. At one particular area you can see two plates are colliding each other at the continental crust, forming the fold mountains. In the middle of the diagram we are seeing two plates moving apart from each other, creating the spreading of sea floor. In the right hand side of this diagram we are seeing a diverging plate which is going inside the crust, creating a rift along the boundary, wherein the zone goes into the interior called subduction zone. So, three types of impacts can be expected during this process. The fold mountains are raised up, sea floor gets spread up and the oceanic zone goes in as subduction zone. The divergent plate tectonics model is shown in this diagram, wherein the plates move apart from each other, which may create a sea floor spreading. The convergent plate tectonics model is shown in this diagram, wherein the plates move towards each other, therein mountain building processes, orogenic activities happen. This diagram illustrates how the plates move from one point to the other. Lateral relative movement of plates varies. It may range from 0 to 100 millimeter per year. Tectonic plates are thick over continental crust and thin over oceanic crust. Plates move because of the Earth's lithosphere has a higher strength and lower density than the underlying asthenosphere. Plate tectonics is a kinematic phenomena. Dissipation of heat from the mantle is the source of energy for plate movements through convection, large scale upwelling and doming. The weakness of the asthenosphere allowed the tectonic plates to move easily towards a subduction zone. Three major categories of driving forces exist in this: mantle dynamics related forces, gravity forces or gravitational sliding, earth rotation related forces, which all come under the subject called tectonophysics. The world's bathymetric observations of 1947 have shown the mid-oceanic ridge of the central Atlantic. The floor of the seabed beneath the layer of sediments consisted of basalt and not granite. Oceanic crust was much thinner than continental crust. It was identified that the sea floor is spreading. In 1950, detailed underwater explorations with geophysical instruments provided magnetic stripping along the mid-oceanic ridges. The sea floor spreading hypothesis was proposed in the year 1966. This diagram illustrates the direction of sea floor spreading at different stages. Pangaea started to break up into two smaller supercontinents called Laurasia and Gondwana land during the late Triassic. By the end of the Cretaceous period, the continents were separating into land masses that look like our modern day continents. It formed the continents Gondwana land and Laurasia, which got separated by the Tethys Sea. When the supercontinent Pangaea broke into Laurasia and Gondwana land, all the oceans got originated. So, this is the point where the origin of ocean happened. The current continental and oceanic plates which are in existence are the Eurasian plate, Australian Indian plate, Philippine Plate, Pacific Plate, Juan de Fuca Plate, Nazca Plate, Caucasus Plate, North American Plate, Caribbean Plate, South American Plate, African Plate, Arabian Plate, the Antarctic Plate and the Scotia Plate. These plates consist of smaller subplates also. Let us see the distribution of ocean basins. Continents naturally divided the world's ocean basins. Continents and ocean basins are the fundamental relief features of the globe. They are considered to be the relief features of first order. Today, about 70.8% of the total surface of the globe is represented by oceans and 29.2% is represented by continents. Let us see the distribution of oceans in the two hemispheres. In the northern hemisphere, we have a different situation, and in the southern hemisphere, we have got a different situation. We have overwhelming dominance of land areas in the northern hemisphere. More than 75% of the total land area is situated north of the equator. Hence, the northern hemisphere is called as land hemisphere. Let us see the ancient seas and oceans. Roughly about 200 million years ago, there were only two water masses called as Panthalassa and Tethys Sea. Proto-ocean surrounding the land mass Pangaea was called as Panthalassa. This is the mother of all the oceans on earth. This was the primordial Pacific Ocean. Panthalassa word was derived from the Greek word meaning all sea. It was existing during the late Paleozoic and the early Mesozoic period. It included the Pacific Ocean to the west and north and the Tethys Sea or ocean to the southeast. It became the Pacific Ocean following the closing of the Tethys basin and the breakup of Pangaea, which created the Atlantic, Arctic and the Indian Ocean basins. This diagram illustrates the breakup of Pangaea into Gondwana land and also Laurasia roughly about 200 million years ago. During the Triassic period, roughly about 200 million years ago, you can see the presence of Tethys Sea, and the Tethys Sea started to shrink during this period. Roughly about 150 million years ago, during the period of Jurassic, the continents started moving away from each other, and this diagram shows the position of the continents during Cretaceous period roughly about 65 million years ago, and this diagram shows the position of various continents and oceans today. Gradually, the Tethys Sea was closed, and this diagram shows the stage 1 of the closure of Tethys Sea. It illustrates the Mediterranean region 20 million years ago. The Tethys is about to close as Africa and Eurasia converge each other. The stage 2 of the closure of Tethys Sea is shown here. By 10 million years ago, plate collisions have sealed off the eastern Mediterranean, trapping small remnants of ocean floor in the Black and Caspian seas. This diagram illustrates the closure of Tethys Sea at stage 3. By 6 million years ago, Spain and Africa collide, raising a mountain barrier and sealing off the western end of the Mediterranean. The river inflow is not enough to maintain the level of the Mediterranean, which got dried up. This diagram illustrates the plate collisions in the Middle East. The impacts are severe in the Middle East due to this plate collision. A lot of earthquakes, earth tremors and other activities happen. Mountain building processes also happen in the Middle East. India has fractured the crust of East Asia into several subplates, which have been pushed far to the east and southeast as the collision has progressed. The diagram shows two stages of the movement of India towards north and northeast. where the closure of Tethys Sea happened. The collision of India and Asia is shown in this diagram, wherein the mountain building process happened where the Himalaya got raised up. The collision of India and Eurasia has created a lot of earth tremors and earthquakes during different periods of time, and all of them have been shown in this diagram with the values of death toll. The present day Atlantic born due to the rift is shown in this diagram. This diagram shows the Atlantic 65 million years ago. By 900 million years ago, a triple junction formed as the supercontinent Rodinia started to rift apart. Between about 800 million years and 700 million years ago, it split in half. This was one of the most significant rifting events of all the times, because it opened up the Panthalsic Ocean to the west of Laurasia and a continent that became North America. We are seeing the Rodinia and also the Precambrian plates roughly about 750 million years ago. We can see that the continents are assembled into a supercontinent. Only this time North America is in the middle instead of Africa. This earlier supercontinent has been given the name Rodinia. The global ocean of Merovia, an ancient ocean that surrounded Rodinia, started to shrink because of the Pan-African Ocean and Panthalassa were expanding. The South China Sea opened as Borneo moved away from China. Also, Japan separated from the mainland, but it is not yet clear whether this was related to the collision of India and Eurasia. This diagram shows the location of Gondwana land roughly about 550 million years ago. This diagram shows the position of the continents during late Cambrian period 500 million years ago. This diagram shows the middle Ordovician period world roughly about 450 million years ago. The world during 420 million years ago during the mid Silurian. This diagram shows the assembly of Pangaea during 350 million years ago, and the early Devonian world is shown, which was belonging to 350 million years ago. This diagram shows the late Carboniferous period world roughly about 250 million years ago, and the position of the world during late Permian roughly about 220 million years ago. The late Jurassic, this is an important period roughly about 150 million years ago. All the continents were visible continents were seen together, and they got separating together from one direction to the other during late Cretaceous period, and during the Tertiary period you can see that India has moved far away from Africa or from Madagascar, and the Atlantic is opening here, and the Pacific got shrink into a smaller ocean. In all these diagrams we have seen the dynamic phase of the earth. The map of the earth is always changing. Not only are the underlying plates moving, but the plates also change in size. The sea level changes over a period of time, covering or exposing different amounts of crust. All of them are reflected in the distribution of oceans on the globe. Understanding the origin of ocean basins is a trivial subject of study. It is very essential due to several reasons. It is also believed that life got originated from the oceanic waters. Oceans play a very significant role on global climate. Let us appreciate the studies on oceanography. We will see some more interesting topics in the next episode.